Okay, Assalamualaikum and very good day. Today I will present about Lab 4 for the section 1. My name is Muhammad Shafiq Aziz. The Lab 4 actually introduce us about the usage of the high voltage DC high voltage. So for the first one, the transformer has been set up with the capacitor and resistor, and the other capacitor 2.4 kilo ohm have attached to the floor pedestal. Then the capacitor 2.4, 2.5 nanofarad have to have connected to secondary capacitor 2.2 microfarad. Then the output of secondary capacitor 2 microfarad has been separate for the picoscope channel 1 and the others go to the VM1. Then the resistance for 280 mega ohm has been connected to secondary capacitance 40 kilo ohm, and the output has been connected to the picoscope channel 2 and VM2 because we want to measure both the signal for the resistance and capacitance. Then for the further explanation, I will pass to Aziz to continue the presentation. Thank you.
Hi, thank you for Shafiq. So next, I will be discuss on section 2. So section 2, just like same as lab 3, that is there are the procedure and the process of the setting on the picoscope, and also for the measurement itself. It's not too different, just a little bit things we have to change. Okay, let's go through. Okay, as we can see, section 2 on this picoscope, it use Ethernet cable and picoscope that need trace in activity of waveform, and there are at slot on the system monitor that causes of numbering. We have two antenna at primary side on the KIT control. Picoscope is a similar of normal oscilloscope that consists 4 channels that connect with measuring section, that is channel A, B, C, and D. Ensure the door must be closed properly. That's to make sure the latch is activated. So make any injection, we must consider looking at the properties on the secondary device that have serial number and check in manual book to choose the right setup. Next is about the divider itself. They are divider ratio at 204 or 4.4 voltage per voltage. Advised in measuring setup either for kit number or picoscope. The 6 terminal in at our frequency measuring terminal, but the VM1 and VM2 for AC, VM1 and VM1 at slot 1 and 2, VM2 slot AC, VM2 and slot 3 and 4 measurement 3, 4, 5, 6 for VM3, VM4, VM5 and VM6. This is alarm that when the red color show up, it not be able to do an injection. Press reset and the alarm trigger will be green. Why change? It's occur because there is something problem exists that the door not closed properly, that we press emergency buzzer that the condition power become off. So this is 3 type. We close the emergency button, close the properly, press the reset button. 3 procedure we have to do to make sure that the red color become green color. So next, for FC setup, we no need to change any setting the manufacturer has given. For customer setup for this lab 4, we can see there are gain and that we can increase and decrease, same as from our previous lab 3. And so for the this is for the customer setup. Then we go to collaboration, put divider ratio to 4.5 as a manual book for the secondary of the first part. System limit only with 7 VRMS as same as lab 3. For this kit, the serial number is limited range, and if you can see we can set the as sampling point, interval accuracy, same, so that this feature can we get in this picoscope and the system of KIT. So the features will have frequency, total harmonic, and distortion frequency on the lock, channel 4A, A and C, and the press button reset. So go on after all the setting, we are ready, and the system start and we change from grid to red. There is sound occur and the switch cloning will be functioning as our safety when the green lamp show that will show the system is ready, then it turn to red when they are not loud. Okay, for this lab 4, the difference is for the setup on the channel A, we must go on for the AC, and the channel B we set on to DC. So we must make sure that the secondary unit devices have been checked out to make sure the serial number, because every serial number have different of the divider ratio. Divider ratio, yes, true. Based on this based on the what we call data from the manual book, as we can see right here. So this is the what we call as the positive bias flow that we can make example for our measurement, that we put the output voltage on 10, 20, 30, 40 and 50. So this is the channel, different channel. So we set the channel B on the DC and channel A for the AC. So for the adjustment of the output voltage, we can set it on the range that we use the button that we provide to at here, if you can see. So the gain will increase and the other side will decrease. Thank you, that's all for me. Next, I turn to Farha Sabrina.
Assalamualaikum and a very good morning. My name is Farha Sabrina. Today I'm going to present on part 3. Students are required to construct the table of comparison between the results of reference and display. Next, calculate the percentage of error between those values. Use the data as provided in the video. Based on overall results and calculation, discuss about the discrepancy between reference and display based on calibration fact. Finally, make a conclusion regarding on the experimental lab session. Okay. This is the result for comparison for analyzing the reference signal and display signal. For 0%, the reference voltage is 1.248 and display is 1.6. So the error is negative 28.21. For 10%, the reference voltage is 13.933 and display voltage is 15.62. So the error is negative 12.11. For 20%, the reference voltage is 28.453 and the display voltage is 29.61. For the error, it has negative 4.07. For 30%, the reference voltage is 42.472 and the display is 43.61. So the error is negative 2.68. For 40%, the reference voltage is 54.783 and the display voltage is 55.94. So the error is negative 2.11. And finally, for 50%, it has the lowest error, that is negative 1.69. This is the calculation of error. In order to find error, reference voltage have to minus the display voltage over reference voltage times 100%. In conclusion, accurate high voltage measurements are required by the electric power industry for instrumentation, metering and testing application. For instrumentation, calibration is an essential stage in most measurement procedures. It is used to set up of operations that establish the relationship between output measurement and the accepted values of calibration standard. This typically involves in the preparation of a set standard that contains known amount of analyzed of interest, measuring instrument response for each standard, and establish the relationship between instrument response and analyte concentration. So, the vertical sensitivity indicates how much the vertical amplifier can amplify a weak signal. This is usually measured in millivolts per division. The smallest voltage detected by a general purpose oscilloscope is typically about 1 millivolt per vertical screen division. Based on overall results and calculation, the discrepancy between reference and display for the RMS is big due to sensitivity, range of scope. The highest percentage of error that can be found is at 0% output voltage, that is negative 28.21%. The lowest percentage of error that can be found is at 50% output voltage, that is negative 1.69%. Okay, that's all from me. Thank you.